Nuclear power, while offering a carbon-free source of energy, presents a significant challenge: nuclear waste. This byproduct of nuclear fission remains dangerously radioactive for thousands of years. We categorize nuclear waste into three levels: low, intermediate, and high level. High-level waste, primarily spent nuclear fuel, poses the most significant risk. This hazardous material emits heat and requires careful isolation to prevent environmental contamination. Every year, the world produces approximately 11,000 tons of high-level nuclear waste. Since 1954, we have accumulated a staggering 400,000 tons. Finding a safe, long-term solution for this growing stockpile is crucial for the future of our planet. The vastness of space, seemingly empty and distant, has led some to propose a tempting solution: launching our nuclear waste off-planet. The idea holds a certain intuitive appeal. What better way to isolate this hazardous material than to send it far away from our biosphere? Proponents argue that space, with its immense distances, could act as an infinite junkyard for our radioactive waste. While the concept of space disposal might sound simple, the reality is far more complicated. Launching objects into space is an incredibly complex and expensive endeavor. Multiple factors, from launch costs and capacity limitations to the risks of space debris and launch failures, make space disposal a highly impractical and potentially dangerous solution. Let's delve deeper into these challenges to understand why sending our nuclear waste into the cosmos is not a viable option. Launching payloads into space comes at a hefty price. The cost is not just financial, but also involves significant logistical challenges. Currently, it costs approximately $4,000 to launch just 1 kilogram of material into low Earth orbit. This high cost is a major barrier to using space as a disposal site for nuclear waste. Considering the annual global production of high-level nuclear waste, the cost of launching it all into space would be astronomical, reaching billions of dollars annually. This is a financial burden that few, if any, nations could bear. This financial burden would inevitably translate into significantly higher electricity prices, making nuclear energy economically unsustainable. Consumers would feel the pinch, and the overall energy market could be destabilized. Moreover, our current launch capacity falls drastically short of what would be required for such an operation. The infrastructure needed to support frequent launches is simply not in place. In 2021, a record-breaking 35 launches carried payloads into space. While impressive, this number pales in comparison to the frequency needed for nuclear waste disposal. However, even this impressive feat represents only a fraction of the annual nuclear waste generated globally. The scale of the problem is immense and requires a solution of equal magnitude. To make space disposal a reality, we would need a massive increase in launch capabilities, requiring significant technological advancements and a substantial investment of resources. This would involve international cooperation and a long-term commitment to developing new technologies. Section 5, a debris-filled sky exacerbating the space junk problem. Sending our nuclear waste into orbit would not only be expensive and logistically challenging, but also irresponsible. Low Earth orbit, the most accessible destination for our rockets, is already crowded with satellites and space debris. Adding thousands of tons of radioactive material to this already congested environment would significantly increase the risk of collisions. Such collisions could trigger a catastrophic chain reaction known as the Kessler syndrome, rendering space exploration and satellite-based technologies unusable for generations. Furthermore, low Earth orbit is not a permanent solution for waste disposal. Even at those altitudes, atmospheric drag gradually pulls objects back towards Earth. Over time, our radioactive payloads would re-enter the atmosphere, posing a significant threat of uncontrolled re-entry and potential radioactive contamination. Section 6. Lunar and solar dreams. Impracticalities of distant destinations. Some propose launching nuclear waste towards the moon or even the sun, envisioning these celestial bodies as ultimate disposal sites. While these ideas might seem appealing at first glance, they present even greater logistical and financial hurdles than initially anticipated. Landing large amounts of waste on the Moon would require a fleet of massive rockets, akin to the Saturn V, which cost an estimated $43.5 billion each in today's money. This staggering cost makes the idea economically unfeasible. Such an endeavor would be financially unsustainable and ethically questionable, as it would contaminate the lunar surface with radioactive material, potentially causing unforeseen environmental impacts. Sending waste into the sun, while seemingly straightforward, is surprisingly complex and fraught with challenges. It demands incredibly precise trajectory calculations and vast amounts of fuel to overcome Earth's gravitational pull and ensure the payload's fiery demise in the sun's intense heat. Even a slight miscalculation could send the radioactive material on an unpredictable trajectory, posing a significant risk to other celestial bodies, including Earth, and potentially leading to catastrophic consequences. Section 7. When launches go wrong, the catastrophic risk of failure. Rocket launches, even with today's advanced technology, carry an inherent risk of failure. While the failure rate has decreased over the years, it remains a significant concern, especially when dealing with hazardous materials. A launch failure involving a rocket carrying nuclear waste would have catastrophic consequences. The radioactive material could be scattered across a vast area, contaminating the environment and posing a severe threat to human health. The Chernobyl and Fukushima disasters serve as stark reminders of the devastating and long-lasting impacts of nuclear accidents. Section 8. A better way forward, embracing earthly solutions. The idea of launching our nuclear waste into space, while initially appealing, proves impractical and fraught with risks upon closer examination. The concept, though imaginative, is riddled with numerous challenges that make it far from feasible. The enormous costs, limited launch capacity, exacerbation of the space debris problem, impracticality of lunar and solar disposal, and the catastrophic risks associated with launch failures make it a non-viable solution. Each of these factors alone presents significant hurdles, but together they create an insurmountable barrier. Instead of looking to the stars for answers, we must focus on developing and implementing safer and more sustainable solutions here on Earth. Our planet offers viable alternatives that are both practical and within our reach. Two such alternatives offer more promising pathways. Solutions that leverage our existing technological capabilities and scientific understanding. Underground burial. Deep geological repositories, carefully chosen and engineered, provide a safe and secure method for long-term storage of nuclear waste. These repositories are designed to contain and isolate the waste for thousands of years. By burying the waste deep underground in stable geological formations, we can effectively isolate it from the biosphere, minimizing the risk of environmental contamination. This method ensures that the waste remains contained and does not pose a threat to human health or the environment. Advanced reprocessing technologies allow us to extract usable materials from spent nuclear fuel, reducing the volume of high-level waste and potentially even creating new fuel for reactors. This not only addresses the waste issue, but also contributes to resource efficiency. Reprocessing offers a more sustainable approach to managing nuclear waste, reducing the overall environmental impact of nuclear power generation. By recycling and reusing materials, we can make the nuclear fuel cycle more efficient and less wasteful. While these solutions come with their own set of challenges, they represent far more practical and responsible approaches compared to the risky proposition of space disposal. They are grounded in scientific research and have been tested for their feasibility and safety. By focusing on Earth-based solutions, we can work towards a future where nuclear power, if used responsibly, can contribute to a cleaner and more sustainable energy future without jeopardizing our planet and the future generations who will inherit it. This approach ensures that we protect our environment while meeting our energy needs.